already recycled. Beautiful work. I'm kidding. So if we are given no angle, not even one, I cannot use law of sines. If I'm given only sides and no angle, I have to use law of cosines, at least initially. And then I can continue with law of sines. But I need to determine one angle, at least one angle with law of cosines. The other situation in which I will start with law of cosines is when I'm given two angles and the angle, two sides and the angle in between. I will start with law of cosines. Two sides and the angle in between. I will start with law of cosines. But one that is mandatory, when I only have three sides, I have to determine an angle. So I have to use law of cosines. Is that better?
Yes.
Perfect. Thank you. Other questions? Is there anything else you want to continue or ask, or we go back to 36? Okay, so let's continue with 36. So let me refresh our memory on, and myself also, my own memory too, what we did here. So we were given side-side angle. And the side-side angle we know has three possibilities. It exists as one possible triangle. It does not exist. Or there are two possible triangles that fit the information or fulfill the given conditions. So in 36, we had a triangle. We wrote law of sines because we were given at least an angle. And from here, we were able to determine sine C. So this is where I want to continue from. Forget about this because I need to explain this one more time. So from law of sines, we found that sine C equals 0.80. We applied sine inverse to both sides, and we got that C equals 53.13 degrees. So here's where the triangle, because I don't want to go back to this. So it was A, it was B, it was C equals 5, it was 40 degrees, A, B equals 4, and C, angle C. Okay, so if angle C is 53.13, lazy people use a calculator like me right now. So 180 minus 40 and minus 53.13, I got that angle A is 86.87 degrees. Okay, so the first possibility, case number one, is A1 equals 86.87 degrees. B, there is no B1 and B2. B is fixed because it was given to us. So B equals 40 degrees. C1 equals 53.13 degrees. Lowercase a was not determined yet. Lowercase b is absolutely fixed. It was given to us as 4. And C, again, is absolutely fixed. It was given us as 5. Okay, if there is a second possibility, B, so A2 will be determined. B is absolutely fixed. It was given to us. We cannot change that. C2, we have to talk about it. Lowercase a2, we have to talk about it. But B is absolutely fixed, and C is absolutely fixed because they were given to us. So we cannot change. We cannot change this. We cannot change this. We cannot change this. These are absolutely carved in stone. Okay. So here was my explanation, but I didn't get the chance to finish last time. So when we go to the unit circle, and we were given that sine C equals 0.8, sine at 90 degrees is 1. So I'm going to say probably about here is the angle whose sine is 0.8. We determined it already. It was 53.13 degrees. However, I will draw a horizontal line through this point, and I realize that there is another possibility, because sine is positive in both quadrants. And the other possibility is 180 minus 53.13. So can anyone subtract 53.13 from 180 and tell us what this red angle is? This angle is 53.13. But this is also 53.13 here, 53.13 degrees. But we want to determine this red angle. Can anyone tell us what that red possibility is? So I'm going to call this as C1. I'm going to call this as C2, So what do we get? It's 180 minus degrees minus 53.13. So what is it? It's 7 and it's 8 and 3 from 9, right? It's 7 and is it, I'm sorry, 1, 3, 137.87. So 3 from 0, 1 from 9, 3 from 9. Oh, 3 from 9 and 5 from 17, 12. So I got 126.87 degrees. Am I correct?
Yep, that's right now.
Perfect. So then this is 126.87 degrees. Now, from 180, I have to subtract 126.87. I have to subtract 40 degrees to determine A2. Okay, what is it? 180 minus 40 minus 126.87. And I got a tiny angle, but it's possible. So, indeed, this ambiguous case results in two different triangles and both triangles fulfill the given information. And the given information is angle B, side B, side C. We haven't finished because we have not determined A1 and we have not determined A2. Okay, and then it will be done. So we go back to our law of sines. I'm going to copy it here so I can move away from that page. So I had sine A. Sine A is 86.87 degrees over A1, which is not known, equals sine 40 over 4. And that's how we determine A1. So cross multiply and divide. So then A1 equals 4 times sine 86.87 degrees over sine 40. Let's stop for a moment and see if you have any questions. Don't let me move on if you have questions, please. Anyone, any questions here? Cross multiply, this times this, so I have to divide by it. So I'm going to share my screen now so we can perform these calculations so we can see. When I subtract degrees from 180, it doesn't make any difference. So we have 4 multiplied by sine 86.87. Close the parenthesis and divide by sine 40. Make sure that the mode is in degree mode. Okay, enter. I got 6.21. So A1 equals 6.21. I go back to my list, 6.21. Now I have to determine A2. So now I have to use A2 to determine A2. So I have the same thing, but I have sine of 13.13 because that's my A1 over A2. That's my A2 over A2 equals the same thing. That doesn't change. Sine 40 over 4. And now I can discard this first two pages. Okay, perfect. The same thing, the same formula. It's just that instead of this, I have 13.13. So then A2 equals still sine 40 degrees, still 4 times sine 13.13. So go back to the calculator. I will call everything I had before and just replace this by 13.13. That's all I needed. And I determined A2. So A2 equals 1.41. So I finally determined everything that I was required to find. I solved the triangle, and this situation is a side angle. Therefore, I always have to be careful because, again, there are three possible situations. One, only one triangle exists, none at all, or two. So in this case, if you have any doubts, how will you check? Let's say we have doubts about our work, or we don't have doubts, but we just want to check. Very simple. Okay, I know this is not a good color, sorry. So all I have to do is sine 86.87 degrees over A1, which is 6.21, should equal sine 40 degrees over 4, should equal sine 53.13 over 5. Sine A1 over A1 must equal sine B over B, must equal sine C1 over C. The other one, sine 13.13 over 1.41 must equal sine 40 over 4 and must equal sine 126.87 divided by 5. If these have huge differences, something is wrong. If they have tiny differences because of rounding error, we are in business. Who would like to check any of this? Can anyone check? Can anyone check the first one? I'll check the second one. Anyone would like to check? No one wants to check? You trust me? Is anyone with me? Okay, the first three are okay. 0.16, 0.16, and 0.16. I hope you can see this. I'm not sure. Maybe, maybe not. I'm checking the last one. Sine 13.13 divided by 1.41. Okay, that's the same. And the last one, because these are the same, I don't have to check twice. And the other one is sine 126.87 divided by 5. All of them are correct. 0.159, 0.16, 0.1599. That's the way you check whether your calculations are correct. Any questions for me, please? Any questions on how to apply law of sines before we move on to a word problem, and then I'd like to work on law of cosines. How do you feel about this one? Please talk to me, anyone? Is anyone with me? Is anyone paying attention?
Yeah, I feel okay.
Okay. I know you do, but no one else said anything, so we move on to a word problem.
Yes, that's fine.
Okay, perfect. Thank you. So let me see where I have all these open here. I like to look at something like this because I wanted to see why we study this. What is it for? So here's an example. So we're trying to find the length of the span of a proposed ski lift from P to Q, from P to Q. So here's a ski lift, and they want us to determine this length. We have this angle right here, which is 25 degrees, and we have this angle, which is 15. So I'm going to copy this figure. $25 and $15. Okay. And we have between, at the base of the mountain, we have 1,000 feet between point P and R. So this is P, this is R, and at the top we have Q, and I think at the bottom we have D. What is the distance PQ? PQ, this distance. So they want us to determine this. Any ideas? Anyone? Any ideas about how to start? Always remember that if we have, like here, 180 degrees, if this is 25, of course this is 180 minus 25 degrees. So you can always determine that because the sum, they are so-called supplementary angles. So the one angle plus the other will equal 180. So I can determine this. Let's call this, for example, X, PQ, that we do not have. And I do know that this is 180 minus 25, which is what, 155. Knowing that this is 15 and this is 155, can I determine this angle up here?
Yeah.
Excellent, because this angle will be 180 degrees minus 155 and minus 15. So 155 plus 15 is 70. 170 from subtracted from 180, so this angle is 10 degrees. Perfect. So now I know this piece, which is 1,000, but I don't know this. And indeed, I do not know the longest side. However, I only need the proportion. I don't need three pieces. Only a proportion is what I need to determine X. Can anyone give us this proportion, please? Will anyone try to give us this proportion? Of course, from law of sines. Anyone, please?
Is it sine 10 over 1,000
Excellent.
equals sine 15 over x?
Excellent. Over X. Excellent. That's all I needed. Known, known, known. Cross multiply and divide by this. So X equals sine 10 degrees in the denominator and this product in the numerator. Excellent. So X is approximately, yes, I will use a calculator. So we have 1,000 Where is my calculator? So we have 1,000 multiplied by sine 15. Remember to have your calculator in degree mode, and over sine 10. Good. 1,490.48. So x approximately 1490.48 and is in feet. So the ski lift should have this length. How did we do this? We determined an angle, two angles, and then simply used the law of sines to determine this side. Any questions on this? Thank you for helping, Blake. Okay, so if you don't have any questions, I'd like to look at law of cosines. So I'm going to share my screen. I'm going to close this and open this. Okay, we already discussed the law. We wrote all three possibilities depending on the angle. It doesn't matter. It's the same thing. They're all the same. Okay. So let's choose an example. For example, in this situation in which we have no angles, we have to use law of cosines. And this is not the ambiguous case because it's not the side-side angle, right? So this situation either exists or it does not. One triangle or it does not exist at all. Any preference, or I will choose? Anyone, please?